Conversions. We did this in Math 10? Oh yeah. So similar, just a little bit different. And like I said, if you've been through Chem 11, well, you got a huge advantage, okay? So again, this is the tough part. Carmen, zip it. Okay, trying to hit the middle of you guys. But this is the book. We're kind of stuck with the workbook. This is what they got in here. I'm following it, okay? So let's start off kind of easy. First of all, you know the difference between metric and imperial. One's good, one's evil. All right, that's pretty extreme. There's a lot of political stuff going on right now about the country that uses the one system, and a lot of people are thinking they're evil, and I'm not going to get political, but so let's not even go there. What country uses imperial? U.S., our good neighbor, yes. Who uses metric? Pretty much, except for like one other country. Okay, how many countries are there? Who's a good socials person? I think, isn't there 200 and something? Yeah, there's a lot of countries. Okay, only 2 of them, as far as I know, use imperial.
There's the US. There's
3? Okay, I stand corrected. I'm not going to research this, but yeah, most of the world uses metric. What's the other word for metric? Well, it starts with an S. Actually, it doesn't stand for standard. Yeah. And the second letter is an I. French is backwards. That's the international system of units. International, more than one nation. Okay? Because it's French, it's system de something or other national. Okay? SI. That's all we need to know. Okay? After I tell you this stuff, we probably won't see it again. But we kind of, we don't need to know the difference like Math 10. But you need to be aware, right? SI is what we're using in physics. Okay? And that's good because it's a lot easier. Which one's bigger? A kilogram of butter or a pound of butter? You said pound? How many pounds are in a kilogram? 2 point, that's an approximation. 2.205 something, something, something. Yeah. Okay, kilograms bigger, right? 5 kilometers of hiking trail or 5 mile mountain bike trail. Are they different? We don't care what kind of trail it is, right? Which one's bigger, mile or kilometer? Mile. All right, piece of cake. A little trickier. Which one's bigger, a liter or a quart? Who likes quart? You said it, but now you're not going to put your hand up because others might see it. Who likes liter? And the rest of you don't have a clue? Yeah, it's tricky. Again, we don't really need to know this. I know a number, but honestly, I had to look it up because I couldn't remember. The number was 946. I've done a lot of oil changes in my life. Okay? And is it a quart or a liter of oil that you can buy here in Canada? It's usually a quart. Isn't that weird? Okay? And right on the bottom it says 946 milliliters. At least it used to. Maybe now there are liters. I'm not sure. But the number sticks in my head, 946. So, if 1 quart is 946 milliliters, let me use a big L, which is, of course, 0.946 liters, which one's bigger, a quart or a liter? A liter. Okay? Because a quart is only 0.94 liters. So 1 liter would be bigger than a quart. Okay. All right. Which one's bigger, centimeter or inch? Inch. Good. Which one's bigger, a gram or an ounce? Again, if you're American, they don't pass you if you don't know this. We don't really care in Canada, but, they're our neighbor. You're going to see every time you guys bake and cook something, it's going to be in ounces. All right? Sorry, it's not in grams, unless you're in Europe. All right, there is 454 grams in a pound. There's 16 ounces in a pound. I think there's 28 grams in an ounce. And actually, an ounce is bigger. Okay? That's all you need to know. That's supposed to say 22 Celsius or 22 Fahrenheit. Now, when they say bigger, the larger quantity, I guess we're referring to which one's the higher temperature? Definitely Celsius. Well, what is freezing? Freezing is 0 degrees Celsius, which is, 32 Fahrenheit, okay? Those of you in chemistry, or you remember in science, maybe you did some. So 22 is below freezing Fahrenheit. So definitely that's a larger temperature, okay? Higher. All right, feel free to read that. Cool stuff. Oh, look. According to this, well, that's the same country, so don't count this twice, right? Why did the U.S. buy Alaska? Keep an eye on these guys, right? Russia. And, okay. I'm not a socialist guy, but anyway, there's another country, and is that a country or is that just a typo? I don't know. All the green stuff, SI, metric. We're going to do conversions, okay? We're going to be doing some math, and like I said, it's going to be tricky. How you start this is with a conversion factor. That's this thing. And remember, we usually put this in a set of brackets, okay? That's how we're going to do these. The difference is, over Math 10, okay, just like this. I want to convert yards into centimeters. I would do this. 1 yard, well, there's no conversion for yard to centimeter. At least I don't know what it is right here, okay? But I do know there's 3 feet in 1 yard. That's a conversion factor. These are equal. There's 3 feet in a yard. This isn't a yard. This is a meter stick, but a yard is pretty close. Does it look like about 3 feet? 1, 2, 3. Okay, trust me. That's how they did this. Okay, now why do I put feet on the top and yard on the bottom? Because if I don't, the yards don't cancel out. Okay, I want to make yards. I want to get rid of yards. I want to make it feet. Yard divided by yard, it's gone. This is now in feet. 1 yard is 3 feet. 1 times 3. Okay, I don't want feet. I want centimeters. How do I get rid of feet? I don't know how many centimeters are in a foot. But what I do know is 1 foot is 12 inches. Feet, foot, same thing. Cancels out. This is now in inches. This is 1 times 3 times 12. That's 36 inches. Okay? Keep going. I don't want inches. I got to get rid of inches. So I put it on the bottom so it cancels out. Inches divided by inches. They're gone. This is now in centimeters. Good. That's what I want. Okay? I need 1, 2, 3 conversion factors. Every number on the top you multiply. Every number on the bottom you divide. It's all a 1, so you don't need to divide by 1. Okay? So 36 times 2.54 is 91.4 centimeters. Okay, that's a quick little review. We did this in Math 10. The difference now, we have these funky numbers, okay? Some of them you're familiar with. Like kilo means 1,000, 10 to the power of 3. Ten to the power of 3 is 1,000, okay? 1 times 10 to the 3, I could write it that way too. It's 1,000, okay? 1 second function, you see that EE button there? There's another way to write 10 to the power of 3. 1 times 10 to the power of 3. Okay? The exponent of 3. 1,000. Okay? Other ones we know. Centi, like centimeter. That means 1/100th of a meter, 10 to the minus 2 in scientific notation. Okay? There's 100 centimeters in a meter. There's 100 centimeters in one of these guys. Right? Milli. How many little lines are on this meter? What does milli mean? There's 1,000. 10 to the minus 3 is milli. Those are the ones we know best. So hopefully you're kind of familiar with them. Mega, have you heard of that? Means a million. Not Megatron. Okay? Megajoules, that's a million joules of energy. 10 to the 6, that's a million. Don't you wish you had a mega dollar? Yes, I do too. Giga, that's common these days. Don't worry about what Bill Gates said 25 years ago. All you'll ever need in a computer is like a few kilobytes. That's all you'll need. Now we're past gigabytes, a billion bytes of memory storage. We're into terabytes. Who's got a tera drive for storage? For Netflix movies and stuff like that. Yeah, that's even getting small. Couple years, quote me, you're going to get a peta drive. Okay, it's another 1,000 more bigger than a tera. Everything goes up by 3, doesn't it? Notice that? Okay, hexa, zeta, yotta. There's going to be a yotta drive in 20 years. Who knows? Maybe it'll be something different. Maybe you won't even need one. It'll all be in a cloud, so everybody can steal it. Okay? The other way, micro, should have heard that before. 10 to the minus 6. That's like the opposite of mega is micro. That's a million. This is a millionth. Okay? Giga is a billion. A nano is a billionth. We use nano when we're talking about wavelength of light because the visible spectrum, it works out to a nice number. Between 400 and 700 nanometers length, that's the part we can actually see with our own visible eye of the electromagnetic spectrum. Okay? We're not going to see these much, but they do exist. Somewhere here in the middle is what we call the base measurement. The base in SI for length, for measuring a distance, is the meter. Everything is based off the meter. It's a kilometer, kilometer. It's a micrometer, a centimeter. Okay? So right in here, see there's not a 10 to the 0? That's where all these guys go. The base for mass is the gram. Everything is measured off of that. It's a kilogram, a picogram, something really, really, really small. Okay? Hecto, we never use much. Deca, we never use much, but we got to fill in the table here properly. Okay? So like I said, after kilo, it just goes up by 3s. We're not going to name more than what we actually need here. So this is going to be our conversion factors. It's not going to be what we're kind of used to. Well, you're still going to use this. Okay, but we got to get in the habit of using this stuff. So for example, if 1 centimeter is, here it is, centi, 10 to the minus 2 meters. That's going to be our conversion factor. If you want to convert from centimeters to meters, vice versa. And a lot of us can do this in our head because you know there's 100 centimeters in a meter. Great. But get in the habit of using this because when you get to zeptos, you're going to be lost and you won't know how to do it. Okay? 1 kilogram. Let's go the other way. That one was negative. This is, you know, that's 1,000 grams. Kilo. Where is it? There. 10 to the 3. Okay? 1 giga. I could use the other one here, liter, but I won't. I'll use gigabyte because we're familiar with that. That's what your computer has. This thing came with 320 gigabytes of memory. Okay? What's that? 320 billion bytes. What's a byte? Look it up. Okay? That's 10 to the 9 bytes of memory storage. 1 nano, if you see an N, that means nano. What does S stand for? Seconds, yeah, okay. So that's the prefix, that's the unit. This one we're familiar with, centimeter. That's just the prefix, that's the base unit. That's the prefix, nano, that's the base unit. Second is, what does it say? 10 to the minus 9, 1 billionth of a second. Pretty short period of time, right? Can't even fathom what a billionth of a second is. But there are things out there that have traveled several kilometers in that time. That's how fast they are. Okay? Now, just note, these numbers always go with the base unit, don't they? That's how you put it in your brackets. Because some people are going to go, do I put this number on the top or do I put it on the bottom? Okay, and it gets a little confusing. Okay, these numbers go with the base units, these guys, okay, when you put it in brackets. A couple of examples, and the book has them, okay? It's one reason why we want to use a workbook, because some of you guys are too lazy to write this down, and hey, it's right there for you. So convert 9.4 nanometers into meters. Okay, so you write out 9.4 nanometers. You put in a conversion factor. They don't use brackets, but I like brackets, okay? Because I hate putting x's there, because then it looks like an x, not a multiply. And your conversion factor, if I can actually read this, they have nanometer on the top, on the bottom, and meters on the top. Why? They want to get rid of nanometers. I want it in meters. The only way to cancel out nanometers, because it's on the top, is to have it on the bottom, so that it cancels. I'm in meters? Good. That's what I'm getting asked. The first thing you should do is look at the units before you even think about what numbers go there, okay? It's a good strategy. Put all your brackets out, and some of these questions, you're going to have like 4 sets of brackets, just like some of you guys did in chemistry, okay? Converting moles a liter into grams. Got lots of stuff to do. It's not just one set of brackets. It's a good idea to put in all the units, make sure everything cancels except what you're getting asked. Okay? So this is just meters. Now, what's a nanometer? Okay? I know 1 nanometer is 10 to the minus 9 meters. You don't have to write that there. They got it right here. I'm just explaining it. The number always goes with the base unit. Okay? It doesn't make sense to go 1 meter is 10 to the minus 9 nanometers. Okay, that doesn't make any sense. You see how that's backwards? Okay? 1 meter is actually 10 to the positive 9 nanometers, right? Put it with the base unit and you won't make a mistake. So, units are good. This cancels out. I'm in meters. Check. Okay? Now, all you do is pull out your calculator and go. Everything on the top, once it works, I multiply 10 to the 9 minus 10 to the power of minus 9. Everything on the bottom I divide, but I don't need to divide by 1. Okay, it's not going to change that. It's not always going to be a 1. You're going to have numbers on the top and the bottom. Okay, that's 9.4 to the exponent of minus 9. If you want to write that, like someone asked me yesterday, I'm okay with that. Or you write 9.4 times 10 to the minus 9, either or. It's the same thing. Okay? Next question. 6.32, what is It doesn't say Okay? The first one is the prefix. What does that little kind of a funky U look like? What is it? I don't know. Let's go have a look. Hey, there it is. That says micro. That's the prefix, 10 to the minus 6. Okay. 6.32 micrometers into kilometers. Now, let me go back here. There is no prefix to go from micrometers to kilometers. But there's this to get to the base unit. And then from the base unit, I can go to kilometers. You have to do it in 2 steps. That's why there's 2 sets of brackets there. Okay? Now, yeah, there is another way to do this. If you can just count the numbers. I'm not even going to teach that. Okay? Probably 3 of those. So you have to do this one in 2 steps. I got to go to the base unit, which isn't here. It's here, and then from there to there. Okay? So that's what they're doing. I won't write this one all out. Just look at the units. Micrometers, micrometers. That cancels out. This is now in meters. But I want to go to kilometers. So I need another conversion factor. Okay, meters I want to cancel. That goes down there. And the only unit I have left is what they're asking for. Kilometers. Okay, kilometers. Same thing. Okay, so the units are fine. Now, I just want to plug in the numbers. This goes with the base unit. That goes with the base unit. Notice one's on the top, one's on the bottom. Put it with the base unit. Everything on the top you multiply. I better put that in. 6.32. Does it matter what order I do this in? It doesn't, but what does that say? 10 to the micro. Negative 6. Yeah, nice. Micro, negative 6. So 10 to the power of negative 6. This one's on the bottom, so I'm going to divide. I could multiply by 1 if I like. Oh, let's do it. But it's not going to do anything, is it? Everything on the bottom divide. Kilo, 10 to the 3. 10 to the power and positive 3. Okay? Is 6.32 times 10 to the minus 9 kilometers. Okay? So what I was saying was, does it matter what order you do it in? No. I could have started here and went 10 to the minus 6, divide by that one, then times by this one. I could have done that one, divide by this one, then times by this one. It doesn't matter, right? But you may as well go from left to right. Any questions so far? Meryl? Yeah, I give that to you. You don't have to memorize a Yotto unit. Okay? Whatever. Exoskeleton. All right, not done there. Those you'll have to do. But now we've done this in Math 10, haven't we? And I hope you've done that in Science 10. And maybe you've even memorized a shortcut. But I'm not going to teach you the shortcut yet. Okay? Don't worry, we'll know it when we get to kinematics. But we're just doing conversions today. I got to go from kilometers to an hour into meters a second. Just look at the units here, guys. I want to get kilometers into meters. And on the bottom, I got to go from hours to seconds. Now, you might know how many seconds are in an hour. Something Dan would know. How many? Yeah. And if you don't worry about it. You know how many minutes are in an hour? 60. You know how many seconds are in a minute? 60. You just multiply them together. He's got 2 sets of brackets here instead of 3. Okay? Kilometers cancels out with kilometers. That'll now be in meters. I'm half done. Hours into seconds. Well, I know 1 hour, I got to put it up there because hours on the bottom to cancel it is 60 minutes. And minutes I want to cancel out and put that in seconds. And then meters per second. See any other units there? That's what I want. Meters a second. Okay, that's what we use in physics because it's SI. Kilometers an hour is imperial. We don't do it. Okay? Plug in your numbers and try to remember this. Meters a second is always going to be smaller than kilometers an hour. Okay? 15.3 Why do they have 3 digits there? Sig figs, because we got 3 there, remember? Want the same number, right? That was yesterday. Okay. There's some there that you will do. Example 3. Density. What's that? That's the mass of a material given its volume. Okay, it tells you. Just look at the units here. Grams per milliliter. Mass per volume. The more dense something is, doesn't mean they get low marks. Okay? It just means it's heavier on the same volume. Okay? Gold is a lot more dense than oxygen, right? Because per liter, cubic liter, I mean, you wouldn't even be able to pick that thing up. Oxygen has a lot less molecules that space farther apart, okay? That's the chemistry part of it. We just need to do the conversions. Some of you guys have done this a lot already, like I said, okay? So, what do? Well, it's a little bit different because I'm using this density. I got to use these units in order to figure this thing out. Grams per milliliter. I am starting with 15 kilograms of zinc metal. Okay? That's what you write down first. Conversion factor. What do I want? What is volume in liters? That's what they're asking for. My answer has to be in liters. Okay? How do I get kilograms to liters? What? Doesn't make any sense. Well, it does if you use this. Okay? So first of all, I got to get rid of kilograms. This is in grams. Okay? I got to make this grams. So this will help me because this density is not in kilograms. So I know that there are, okay, in 1 kilogram, there's 10 to the 3 grams. That's on my conversion table. This is now in grams. Is there something to convert grams into liters? No. But there's something to convert grams into milliliters. That's what goes right here. You need to decide if you want to put it upside down or right side up. I got to cancel out grams. So I need to have grams down here, right? So this is 7.13 grams per 1 milliliter. If I write this like I would like to visualize it, that's what it says, right? That's density. 7.13 grams in every 1 milliliter. Doesn't matter if I write it like that, or in this case, I got to write it upside down because I got to cancel out grams. Grams are gone. This is now in milliliters. That's the only unit I have. How do I make that liters? Well, now I go back to my table again, and I know that, okay, 1 liter is, nope, I want the number there. Okay, 1 milliliter is 10, milli means minus 3, 10 to the minus 3 liters. Milliliters cancels out, and guess what I got left? Liters, which is what I want. Okay? Look at the units. Make sure they all cancel out except the one you're getting asked. Then put in the numbers, then the rest should be easy. Everything on the top you multiply, everything on the bottom you divide, and you better get that. And if you're really good, you put it with the right number of sig figs. Okay? A little trickier? For sure. Okay, you got 3 of those. Are you going to get 1 of those on your test? You betcha. Are you going to have a quiz on this on Monday? Yes, you are. So I do it tomorrow, but tomorrow I'm going to have a little lab, okay? Okay, hang on. Not done. 1 more. Last one. This one you may not have had so much in Math 10, okay? But it's not that big of a deal. Let me explain. Convert 0.35 meters cubed. How many significant digits are there? Who likes 3?
3.
Who likes 2? Oh, who's taking chemistry? You guys haven't taken chemistry. What's that 0 there for? It's not there for anything. All that's there for is to place the decimal. It's not significant. Okay? There's only 2 significant. Cubic meters. What is that? Is that a distance? Is that a velocity? Is that a volume? Dan, you can sit somewhere else, starting right after I'm done. There's only 4 per table, and you're the odd man out. What's length times width times height? Is that like a formula for volume? Dimension times dimension times dimension. Meters times meters times meters. That's a volume, right? Okay, I don't care if it's a solid. People kind of like, what? How can I have a volume of wood? Well, how can't you? You just multiply the 3 dimensions together, okay? People like to think sometimes they only have volumes if it's liquid. It's not true. Okay, I want to put that in milliliters. Okay, so the problem is, because this is cubed, how do I cancel out an M3? I got to have 3 of them down there. Okay, so it's the same conversion factor. I know that 1 centimeter is 10 to the minus 2 meters, but I just got to do it 3 times because I got 3 m's up here. I need to have 1, 2, 3 m's down there, okay, to cancel it out. Now, do I have to write this out 3 times? Not necessarily. I could just cube it. Okay? It's hard to see up here, but of course it's better in your book. That's what they're doing. They're cubing it. You either or. I don't care as long as you get the right answer. But to cancel out 3 m's, you need 3 m's here. Okay? Now, what's this in? 1, 2, 3. Right there, that's in cubic centimeters. How do I get milliliters out of that? Well, chemistry kids know that 1 milliliter is a cubic centimeter. Okay? Sometimes called cc's. They give you an injection, 10 cc's of morphine. You won't be able to do your homework. But that is exactly 10 milliliters in volume. It's exactly 10 of these cubic centimeters. It's the same unit. Okay? That's why SI is so nice. It kind of works nicely. So if you know you got so many cubic centimeters, that's the same as milliliters. Okay? So that's your answer. It's the same thing. You just got to do it 3 times. Okay? Okay? Just look at the units. First thing you do, cancel the units. Okay. That enough for today? Okay. That's where I'm stopping. So this is just part 1. Part 2 of this lesson is graphing, and we won't do that till like Monday. Okay, so tomorrow we'll go back and do 1.2. So page 23 to 26, all, that means like these guys, the other ones I showed you, all the practice problems, okay? So that's, I don't know, about 10 or 12. One thing you need to know, though, where is it? For this question, you've seen it. It was in Science 10. Lewis? I'm not done yet. Sit. Speed. Da 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 da. Time. Da 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 da. And they want to know kilometers. What's kilometers? That's a distance. You remember that formula that relates speed and time and distance? Have you seen this? I don't know if you like that, but what's on the back cover of your book? The first kinematics formula you're going to get. It says V is the change in distance over the change in time. If you need a distance, multiply both sides by t. T cancels out. Okay, so distance is the product of velocity and time. Okay? If you like using this thing, distance is the product of velocity and time. Velocity is d divided by t, or time is d divided by v. That's how that little triangle works. Okay? So I don't care if you guys like to use this, or you just want to use that formula and algebraically manipulate it, but that's the formula you need for this guy. Okay? We're not doing kinematics, but the problem's there. So, but that's science 10 actually. Okay, that formula. Okay,